Okay, so today we'll continue our discussion on interrupted xenoliths, which I have been working on for a few days now. So, what Professor Jang was suggesting last day, to do some probability density plots. So, for each elements to see if there are variations. So, I have done these plots. I would ask Professor Dr. Jang if he was speaking about these plots or he meant something else.
Yeah,
Dr.
sure.
Jang?
Go ahead. I think this, yeah, go ahead. I think, yeah, talk about this plus
Okay.
and why you are working on it because we have a couple of people that haven't been here. For example, Roland, I think it's the first time that Roland went into this Garnet project. So that's Trisha. She's first time for her to come to this program. I think Ujesh has been seeing a little bit more. Yeah, please tell us that what that's
Okay.
why you are working on it and why. What do we
Okay,
like to?
so I have done these plots. As you can see, I have calculated the atoms per formula unit in the structure of the garnets as they should be, and then I have done this histogram and probability density plot. Now, why it's needed to be done? It's a part of a very interesting part of data filtering. So initially, to get plot things, first I got rid of all the nil values because they were unnecessarily complicating things. So secondarily, what I try to do is I try to do these types of plots. And these plots are telling me that these particular values, like for garnets, this is for a silicon Si at the tetrahedral side. So it's actually varying. It's actually has a small spread of data. So probably most of the data it's actually good. So we can use silica with more or less impunity. However, in case of MG, we are seeing a slight deviation from a Gaussian trend, and it's becoming more or less a skewed, a left side skewed plot. So probably some of this data that's falling here that has low probability density, so they could be problematic. So will be focusing on them. We will study them. We'll go through the papers, and then we'll check if they're all right. If they're all right, we'll use them and we'll investigate the causality for their dispersion from the norm, or we'll discard them in case they are faulty values. So this is I have done it for all the major structural elements that could be that are present in the garnets. As you can see, manganese concentration is pretty low in all these type of xenolithic garnets. Same and magnesium, iron, and silica has considerably higher concentration as it should be. The calcium concentration is also varying, and it's also mostly a Gaussian trend with a slight slightly skewed the trend of it. The histogram you can also see it here, and the titanium concentration is also peculiarly low. I mean, it's a high in some of the interrupted volcanics, but definitely not in the xenoliths. The chromium concentration, however, is showing a more or less plateau. So this is something we need to focus on. Fe3 plus again has an extremely low concentration, almost nil to very less 0.05 APFU. So then we do need to get rid of some of these. Probably some once we analyze some of the chromium plots, probably we can get rid of some of it. So now I have done some of the major elements plot with some of the data filtering on. Not all. I need to work a few of them again. So these, as you can see here, these plots like this eclogitic xenoliths, they have a high calcium concentration. We have also seen it earlier. All these xenoliths are quite devoid of any ferricon concentration, except a few, as we have also seen previously in those histograms. Chromium concentration is showing an wild variation. It's a higher in the peridotic xenoliths, although the peridotic xenoliths also has a wider value here, and it's also overlapping against the lazolitic xenoliths, which also has a wider value. So chromium, as I have already said, that it's maybe problematic, as we have seen from the histogram. So we will look further into it. This is the APFU plots. We can see similar things. The stretch of calcium is higher, the stretch of magnesium is lower. The chromium concentration again showing a larger trend. So some of these chromium values could be untenable to use, and we will definitely either get rid of them or study the reason for their for deviation. These are some of the three-dimensional plot. As you can see, this is calcium, iron, and manganese. This is chromium, aluminium, and iron. So this can actually help us visualize better in terms of these elements. So as you can see, like this chromium, aluminum, iron, both are could be present. Like chromium and aluminum both are present in the octahedral site. Calcium, iron, and manganese, they are all present in the distorted octahedra or the site.
Okay.
So
So so Tuin, is this plot 3D plot from the, let's say, carbonated project? Because I think,
no, these plots are actually in Python. I have done them in Python.
yeah. Could you ask their carbonated project, because I think they have a 3D plot that is better
Yes,
than
yes, I
this.
have I have that because I have used it previously also in the previous days plotting. It was just that
Mhm.
I was working on this Python, so I have done everything there. I have this plot. Next
Okay,
day I
okay,
will show you.
okay, okay.
Okay.
Okay, that's okay. Okay, could you move back?
Yes.
Uh, yeah.
Sure. This one?
Okay, I think yours freeze. Yeah, this one. Yeah, I think try to make more ternary one,
Yes, I have
rather than
Ternary. I'll
3D.
show you. Uh, just
Okay, later. Okay, that's okay.
yes.
Okay. Pre move further early on,
Okay.
the previous one.
Oh, previous one.
Yeah, and the previous one, previous. Yeah, previous. Yeah, I think yeah, and here you get rid of all the zero values. I should say that everybody that pay attention to zero values, or so first and to the missing values too. So we should first make it clear what does whether it is a zero or whether it is empty, because empty means this data has not been analyzed and we don't know what's the real value. It could be 1 ppm or it could be 100 ppm or 1000 ppm. Zero means it's extremely low, so it's lower than the detection limit, and therefore it probably is a value that is very close to zero, so that is zero. So when it's empty or have not measured it, we took the value as NaN, so it's none. So later on, this data set will apply various machine learning tools to work on it. So for different machine learning codes, some of it is okay to run if it is NaN, that is its empty value, that's okay. And for some programs, especially statistics, using R to do very different things, then we need a number for it. So you cannot use a NaN or empty value for it. So we have to assign value for it. So many different ways that people could assign value. People could assign the average. People could assign the middle position number, or many other possible ways people could assign number to replace NaN in those situations. So yeah, so for the initial data set that we are working on now, because we are doing we are working on the data to do to try to check the data, and then we are going to do the data cleaning. That is, we will do the data
Hello.
processing. Doing different. Hello, could you hear me? Uh,
In between the your voice didn't come.
okay, so uh, so I mean that for everybody that should be clear what is NaN, empty values, and what is are zero values.
Yes.
And what we are working on now is checking the data, and later on, next step we're going to do is the data cleaning. And it means we should make the data ready to be applied for machine learning. That is, we should know that exactly which value is for each location, even though we could take the value as NaN, because we could use other values to replace it later on. And furthermore, we also need to make the value right, because for a lot of for the tables that we have, a lot of them are during the extraction, there could be various different problems with the data. For example, is in a wrong column, for example, or some values with a comma, which basically makes the machine learning extremely hard to work on, because computers could not read the comma or could not read dash. So this is data cleaning is just like a sample preparation for geologists or for chemists. So we have to prepare the data ready to be processed by computers. Okay, so that's just my statement. So please move forward rather than backward, and to the 3D one, and move fast so you don't have to tell us all the details.
Okay, now see there is
And then continue your step.
these are some of the
Oh, yeah,
ternary
next
plots.
one. Yeah. Could you say a little bit more about it?
So here, what these are, as you can see, this is an plot between almandine, grossular, and pydope. So what we have done is from the values in the distorted octahedral site, we have calculated the Garnet n members from it divided into almandine, grossular, pydope, spessartine, uvarovite, and then we have done this ternary plot. So most of the data is actually falling into this almandine, grossular, pydope ternary, with bulk of the data, bulk of these are eclogetic the type of it, which is exactly at the center of it. So between the between Fe, calcium, and Mg. Next, so this is a 3D plot of the same thing. You can visualize it better here. This is almandine, grossular between these two end members, and as you can see, pydope is here, almandine, spessartine. So this is our three-dimensional plots. So in case of trace element, as I have shown earlier also, yesterday also, you can see that there is clear two distinct trend between tourmaline and between lutetium ytterbium plots, and also as you can see here in the later ytterbium versus yttrium plot. So these it's although it seems that both of these eclogetic xenoliths are in both groups, but it's principally dominating the earlier one, the one with higher lutetium concentration, whereas these orthopyroxene type xenolith types are in the second trend. This is some other ternary plots between APFUs mineral like calcium, manganese, Mg. As you can see here, previously we were discussing about the types of garnets there are. Now we are directly talking about the elements, and this is the trace element. As you can see, most of this data has high yttrium concentration, except some of these cognate xenoliths which has higher ytterbium and lutetium concentration. Although yttrium concentration is significantly higher than other trace elements, which is expected in case of garnets. In the case of H2O, the only data that's available is actually from clinopyroxenite. It's a clinopyroxenite type xenoliths, and all this data is actually from a single publication by Lee Hai Young 2018. It's from the Sulu province. It's a ultra high pressure province. From which these xenoliths were formed. So I was reading that paper a bit. I need to read it further, but from what I understand, these pyroxenites are they don't show much alterations because events, and ultra high pressure events may not have affected them much. So this is these waters actually the water concentration in Garnet is actually varying between 55 to 100 150 1500 ppm, and in the pyroxenes also it's quite high, like 2500 ppm, as mentioned in the paper. So this must represent the some of the water content in the mantle, which is the parent source of it. So thank you.
Okay, so do we have any questions for Tuhin, or comments?
I actually wanted to clarify how you divided the work between people. I mean, as far as I understood from the previous lecture, Urmi is doing eclogetic garnet, Tuhin is doing mantle garnet in general,
No, these are
and
mantle xenoliths.
someone else. Huh?
No, these are see basically right now. Yes, you have raised a very important point here. Like
Yeah, Tuhin. Yeah, I think Tuhin, you could stop sharing the screen.
oh, okay.
And then I think your voice will become better.
Okay.
Yeah, you could
So
stop the screen. Yeah.
So okay, Natasha has raised
No,
an
no, no.
important.
Please stop sharing the screen.
I have
Please stop
stopped
sharing
sharing.
the screen. Yeah.
I have stopped sharing.
Okay. I see from my side. I still see you are sharing the screen. Okay. Okay. Now you stopped. Okay. Okay. Now. Okay. Go ahead. Go ahead. Let's talk. Yeah. I think
Okay,
it's easier.
so Natasha has raised a very important question. So what me and Urmi are doing is actually we are working on two separate databases. I am working on GeoRock database, whereas Urmi is working on ArthChem databases. Now the point you have raised actually leads to the conclusion that we need to merge these two databases, and it's a very important work, and we are working on it. So it's right now me and Urmi is working in two different separate paths. However, they are intricately related to each other. As you can see here, like what I try to my objective was defined in first I plot all the garnets from the GeoRock database. There was some 43,000 odd data. So then I tried to see that the bulk of the data was from which part of it. So I have realized it's from the intraplate volcanics, and most of the variations we are seeing were also.
Okay.
Hello, could you hear me?
Okay.
Hello.
Now you're back. Okay.
Okay.
Yeah.
So
Yeah. We could hear you now.
okay. So when did you lose me? At which point exactly? Anyway, I'll start from beginning.
Actually, I forgot. Yeah. I think you were talking about that you and Wumi were working on different things, but I did
Yes.
not hear what was Wumi working on.
Okay.
So as far as I understood, there are just two different databases, and Urmi took one of them and you took another one, right?
Yes. So now the important task remains to merge these two databases. It's like two intricately related ones, but we need to merge it. Obviously, it's a valid point,
Mm-hmm.
and we'll be working on it soon, because otherwise it will be difficult, and it will be basically a repetition of works. So what I was doing, like
Mm-hmm.
I was trying to see the bulk of the variation of the GeoRock database. GeoRock database contain like 43,000 data on garnets. So I tried to see, like, for the intraplate volcanics,
Mm-hmm.
it contains bulk of the data, like 34,000 data, and it contains most of the interesting things, like all the variations and every other things there is. So I focused on intraplate
And
volcanics. Okay.
how do you distinguish different types of garnets? For example, majoritic or TAPP phases. If you get once, how would you
From the composition of
separate
it,
them?
obviously, I mean, we have this major element composition in the data. So if it's
But
like we are focused.
for the manganese, however, I saw that there are a lot of values higher than 0.65, which is obviously not mental origin, or at least they were highly altered. So, we,
In case of
what?
manganese, you say?
How do you distinguish majoritic and? I mean, when you showed this graph, this histograms about
Yes.
about the amount of samples containing manganese, and there were several samples which had high manganese concentrations, such as 0.65, 0.7, and even 1%.
No,
So
no. I think you have. I mean, you may have missed something, because all the manganese you are talking about atoms per formula unit, right? You are not talking about
yes,
oxides.
this
Atoms
is
per
it.
formula unit. Yes. So atoms per formula unit scale, these manganese are like pretty much limited to like 0.05 APFU. So they're extremely low to almost nil manganese content. So I can share the screen again if you'd like. Natasha?
Oh, no,
I,
that's okay.
Okay.
that's
Uh,
okay. We're talking. You could upload your PPT in the Slack. I think it's easier rather than
Sorry?
you share the screen. You could upload it in the Slack.
oh,
Yes, I will
Yeah,
upload it into Nutscode.
you could upload your PPT. Yeah, in the Slack. I think that's easier, so people could
Okay.
download it and see your Slack.
Okay.
Yeah, it will be better than sharing screen because that will lower your voice quality. Yeah, so go ahead, Natasha.
Okay. So I will upload it after this talk, and you can see that manganese concentration is actually pretty low. So it's in all probability there could be mantle garnets, most of them, bulk of it. I mean, right now we are dealing with xenolithic varieties, so by association we can assume that most of them are from mantles. But obviously, if there are some points we find, some garnets we find that are not of them, then we'll get rid of it. Like manganese, you have mentioned a point. Like manganese could be very important here. Do you have any other element in mind which we can use, Natasha? Did I again break?
I think Natasha is out.
Oh, Natasha is out. Okay.
Okay. Yeah. I think the connection probably is not good on her side neither.
I'm just happy to see
Okay.
that it's a
So,
global problem.
yeah. It's not your problem. Okay. So, yeah, I think we will continue to merge on data, and then because the very first step is to let's say locate the data set that we could later on move to the second step, that is later data cleaning. So I think you and Wumi are on the track. Yeah.
No, so this data, these histograms and probability plots I have made. So the plots which are like extremely skewed, it's not Gaussian at all. So how do I approach them? Should I go? I mean, by case basis, check for the publications like this.
Uh, Yeah, we could do some of those, but I don't want you to do all that. So that you could, as a team leader, you could assign the work to Roland, to Ujash, and to Trisha to work on
Okay.
some publication to investigate them. So that's
Okay.
normally how we begin by it. So yeah. So everybody, you could send to him the time that you will be available in the coming days. For example, Ujash maybe say, okay, for the rest of this cycle. So each time we talk cycle, that means normally start from Saturday and ends on Friday. So you could say at the end of the cycle before Friday, you may have like say 3 hours work on it. Then so he knows that probably that 3 hours you could only look at one or two publications, something like that. So that's how we divide the work. Yeah, we do need some investigation, that's for sure. Because normally for machine learning, later on, as I said, the first time is doing the data set, the second time data cleaning, and third time we're going to do machine learning. And normally for machine learning, we will train a model, and in order to train a model, we will have a supervised training. That is, we'll give the model some right answers to it. And in order to give the right answers, we will read some publication to assign the values or telling the code that this one belongs to this group, that one belongs to that group, and train a model, and later on this model could be very powerful to solve other problems. So yeah, from the beginning we need to do it, and in the process, the data cleaning we also need to do some paper investigation, and in the machine learning part also we need to do some paper investigation. That's why we need people with expertise in geology or in chemistry to move this forward. Okay, I think that's pretty much so much about it. So Treasure and Ujash, could you open your mic respectively and talk about your comments, ideas, and your possible time, or any of your understanding that there's something that you don't understand. So
Hello.
Ujash, yeah. Now, just now your voice was very weak. Now it's good. So go ahead.
I think my first meeting is good since there are a lot of topics that I should be dealing more, especially, and it's very interesting. So I think I will read about more of the topic and watch the videos. So I have, as much as the meeting, I have, it's not very that clear to me since this is very new, but I am willing to study about it since there are a lot of topics that are very familiar while the discussion is going on. So that's all the comment that I have. Thank you.
Okay, thank you.
Hello? Hello? Am I audible?
Yes, but could you speak louder?
Yeah, actually, I am working on the EarthChem data, and like as Tuhinda already said to me, I collected the data, and there
Please
are around
a
9,000
a
data.
bit louder, please.
Hello? Am I audible?
Not to me, uh, Dr. Zhang.
Yeah, I could hear Ujash. Ujash, you could also speak louder.
Okay, I have assembled the EarthChem data, and I guess by today I'll be uploading that, the entire CSV file in the NUTS code only. And next, Tuhinda gave me a work that of converting the carbonate data to English, I guess. So I'll be doing that next. I think if Tuhinda gives me something else and inform me, I guess I'll be doing that next too. Because the
Okay,
EarthChem data
okay,
is almost done.
okay, okay. Ujash, I think Tohin could not hear you, but you could chat in the Slack later on. Okay, I think that should work out. Uh, okay, so Treasure probably will spend more time in practicing. So Ujash could help Tohin and Wumi a little bit on it. So yeah, yeah, I think that's pretty good. So let's move forward with it. And Wednesday, maybe you could meet again. If not, I think Tuhin could present what is available. And one thing that I make Tuhin, you could um, think about is that, okay, for Wednesday presentation, in addition to the pictures of everybody, also could you put their name of everybody and their institution on the cover page, okay?
Okay.
So also other than that, I don't have anything else. So yeah, I think we'll communicate more by Slack, and for everybody, if you have any questions, feel free to upload the questions in the Garnet group or in the ZGU or Theta, let's say Slack chat, because
Okay.
everybody's there. So people should be happy to answer your questions in machine learning or any other questions on it. Okay, great.
So,
okay, have a good.
Dr. Zhang, we will convene tomorrow, or we'll just go directly.
Why not? Yeah, why not? Let's meet again at 9 p.m. Yeah.
So
please.
tomorrow same time probably, or Udjashi was asking if we can push it to half an hour, 9:30.
Yeah, sure. Yeah,
Okay.
let's do 9:30.
So
Okay.
Urmi could present tomorrow then what she has done.
Yeah.
I understand she is a bit busy with some of his
tomorrow.
paper submission and other things. So probably tomorrow she will be free.
Okay.
Okay.
Okay, great.
Okay.
Okay, great. Okay, everybody's great. Okay.
Okay. Bye.
Okay, chat again tomorrow.
Bye.